This next portion of the lesson is to go over some of the ways we can reason our way through simplifying rational expressions. And in the lesson, you are given this: x squared plus 1 over x squared plus 2. And the question is, does that equal 1/2? And what we're really trying to drive at there is, are you able to cancel out the x squares? Is that something that you are allowed to do? Now, if you've kind of jumped over this, there is a section of your assignment that asks you to really stop and think about this, try some different things, and then you're going to answer a couple questions based on your own conclusions. Do not go back and change those answers. You will not be penalized if you get them wrong, but it does help me to see where you are and kind of what kind of conclusions you're drawing. Okay. Now, in this video, we're going to look at two different ways that you can reason your way through this. So you're staring at your EOC, you're looking at something like this, and you need to pick an answer choice. And you want to know for yourself, can I cancel that out? Does that work? So two ways that we're going to look at this is we are going to do this by plugging in x is equal to 2. So on the next slide, I actually wanted to rewrite the problem here. So we've got the x squared plus 1 over x squared plus 2. And what we're going to do is we're going to plug in x is equal to 2. Because if x is equal to 2, then we should be able to see like what would or would not cancel out. Now, I think we're actually going to do this by hand. Okay, so I'm going to move. So we're going to do x is equal to 2. Now, if you're wondering, well, where did she get x is equal to 2 from? I just picked a number. You could pick 1. You could pick 3. You could pick -1. You do want to maybe pick more than one number, because there is one number for which like it will do something different. So maybe pick 2. But let's go ahead, and what we're going to do is we're going to do 2 squared plus 1 over 2 squared plus 2. And 2 squared plus 2 squared is 4. And then we have 4 plus 2. And so then I end up with 5 over 6. And the question would be, is 5 over 6 equal to 1/2? No. No, it is not equal to 1/2. So if you've got like a pie, love pie, and you slice it into 6 slices, having 5/6 of that pie is not the same as having 1/2 of the pie. So that is the part that I want you to write down. I put Desmos on here thinking that I would like plug it in. Well, I guess we could still like do that. So let's say you're just not super confident with that. It always makes me so uncomfortable how that changes my view. Let's see. There we go. So now to do fractions in Desmos, it's actually beneficial to hit the fraction bar first if you have not seen that. And then you can just type it in, 2 squared plus 1 over 2 squared plus 2. And you can clearly see that like that is not 1/2. And if you wanted to do like 1/2, you type them both in and say like, no, they are not the same. So one of them is 0.833333 and the other is 0.5. So if you're really not comfortable with fractions and you look at 5, 6 and you honestly don't know if that's the same, or if you have messy fractions, like it's something really messy that it's just not obvious whether it's the same, then yeah, absolutely go ahead and type that in to Desmos. Now, here's another way you could reason that out, and that's by graphing it. So if you wanted to know, is x squared plus 1 over x squared plus 2 equal to 1/2, is you could actually generate the graph. And the way you would do that is you would graph it as a function. So you would say y equals x squared plus 1 over x squared plus 2. And then on the bottom one, you would just say x squared is equal to 1/2. And what you can see there is that that is not the same function. Now, right here, you can see that there is one spot where they intersect. So if you had an equation, you wanted to know when it equaled 1/2, then you could do it that way, find the point of intersection. What that tells you is that when x is equal to 0, then yeah, that function is equal to 1/2. But generally, no, they are not the same. And so if we look at the one that we just did, I plugged in x is equal to 2. Okay, so x is equal to 2. Well, actually, if I slide that back and forth, you can see that it's always equal to 1/2 because it's a horizontal line. And when x is equal to 2, it's obviously not 1/2, it's somewhere else. And so you're looking for matching graphs there. So here's the conclusion that we need to take from this. We cannot cancel common terms. Okay, so common terms. Making sure I'm matching what's in your lesson. Only common factors. Okay, therefore, and if you remember, that is the math symbol for therefore. Therefore, we must factor the numerator and denominator before we can cancel anything. Okay. All right, and I don't remember off the top of my head what your blanks were, but I'm pretty sure they were terms, factors, and factor, and maybe cancel. Now, here's the deal. Way back when I first started teaching, I taught an Algebra 1 class, and we were doing something like this in Algebra 1, and I kept saying this: we can't cancel common terms. We can't no common terms. The kids kept canceling common terms. I said we can only cancel common factors. This is where vocabulary is really helpful. You need to know the difference between a term and a factor. Terms are things that are added or subtracted, and factors are multiplied. And so that's why if you have x squared plus 1 over x squared plus 2, these are terms because of that plus sign right there, and you cannot cancel them. You can only cancel common factors. And the reason you can cancel common factors is because of operations on fractions. It has to do with multiplying fractions and how multiplying of fractions works. And that's really not something that we should need to go over in Algebra 2. I know that it might be a sticking point for some of you, but when you're multiplying fractions, you just multiply straight across. And so that allows you to cancel common factors because they would equal out to 1. But when you're adding fractions, then you need a common denominator. So if you're adding them, you would need a common denominator. So it would be like AD over BD plus CB over BD, I think. And so you would not be able to cancel them out there. So that's the reason why. So that should get you through the next chunk of your lesson. And there we go. It should get